Hi everyone, and welcome to the Central Tendency Statistics lecture video. Central tendency statistics are designed to describe the typical values within a dataset. Generally, as you can tell from the name, central tendency statistics are located in the middle or the center of the distribution. We're going to talk about three different central tendency statistics in this lecture. I'm going to show you how to calculate each statistic by hand, but since you should have already had a statistics course, I will not go in depth on these calculations. However, there are several supplemental videos on my website that I've created for you to help walk you through the calculations step by step if you would like more guidance. So what are our three statistics? Mean, median, and mode. Mean is represented by a capital X with the line over it, X bar. Mode is represented by a capital M with a subscript O, and there really isn't a standard representation for median, so I use MDN for short. So let's start with the mean. It's the most complicated of the central tendency statistics, but I think you'll get the hang of it easily. The formula for the mean looks like this. It means the sum of all x values divided by the total number of x values. Let's do a practice problem to illustrate. Mary wants to find the average IQ in her classroom. She has 5 students and their IQ scores are shown here. So we know that the average is found by adding up all of the x values and then dividing by the total number of x's. In this case, the IQ scores are the x values because they're the variable we're interested in averaging. So we add up everyone's IQ scores and then divide by the total number of scores in the data set, which is 5. This gives us 495 divided by 5, which then gives us 99. So the average IQ in Mary's classroom is 99. Not too bad, right? Now here's the issue with the mean. The mean is calculated using everyone's score, so all it takes is one person to mess up the average for the whole group. To illustrate that, let's look at two variations of Mary's classroom. The first column is the original scores that we just calculated. The second and the third column are the same, except for one score, Jacob's score. In column 2, Jacob's score is lowered to 10. This lowers the average from 99 to 84. Remember that the average is supposed to be in the middle, but 84 is lower than all of the scores except for Jacob's. In column 3, Jacob's score is now increased up to 200%. Again, this time his score pulls up the average to 122, which is higher than all the scores except for Jacob's. In both of these cases, Jacob's score is what we call an outlier. This is an extreme score that doesn't represent the rest of the data set. Because of the way the mean is calculated, outliers can have a significant effect on the calculations. This is why we often use the median values instead of the mean. The median is the middlemost value in the dataset. It's not a calculated value, it's simply identified. We find the median value by using this formula here. We take the number of values, add 1, and then divide by 2. That gives us the position of the middlemost value. Now the caveat here is that whenever you divide by 2, you can either end up with a whole number or a 0.5. If the median position ends in 0.5, then we have to do one more step, and that is to average the two values on either side of the position. Again, let's do a practice problem to show you what I mean. In this example, Julie analyzes the number of car accidents that each of her friends has been in with the goal of finding the median number of car accidents. She surveys 11 friends and finds the following data. The first step with median calculations is to make sure that the data is in order. The good news is that ours already is in order, so we can create this chart here. The top represents the X values that Julie collected. 0 car accidents, 1 car accident, 4 car accidents, etc. The second row represents the position in the data set. Since there are 11 people surveyed, the position numbers run from 1 to 11. Okay, now what about that position calculation? Remember that it's n plus 1 over 2. In this case, the total number of people collected is 11. So we do 11 plus a 1, which gives us 12, and we divide that by 2. This tells us that the median position is 6. Now the super important thing with median is that you do not stop there. The calculation we just showed shows us the position of the median, not the value of the median. So now we need to look at the actual data set to see what the value of position 6 is. So person number 6 in the data set reported 3 car accidents. So our median value is 3. Now let's try the same example, but this time Julie adds another friend. So her total N is 12 people instead of 11. When we do the calculations, we find that the median position is 6.5. This means that we need to figure out what the value of persons number 6 and persons number 7 are, and then average them together. So we make sure our data is in numerical order, and we add the position numbers like before. Then we identify position number 6 and position number 7. Those people have reported 2 car accidents and 3 car accidents respectively. Now we use the mean calculation that you just learned to find the average between the two. We take the 6th value plus the 7th value, 3 plus 4, and then we divide by the total n in our analysis, which is 2. That gives us 7 divided by 2, which gives us a median value of 3.5 car accidents. So there is one extra step when the data set includes an even number of values that we don't have to take when the data set includes an odd number of values. We can see the advantage of the median by looking back at our example from before. I've rearranged the columns to make sure that the scores are always in order from highest to lowest. We know already that the mean changes for each column, but the median score doesn't have that issue. Up at the top, you can see my calculation for the median position. Maybe. There we go. They tell me that the position value that we're looking for is the 3rd position, which is 100 in all 3 columns. So even though Jacob's score was changing up and down, the median wasn't impacted. This is why the median value can be super useful when looking at variables with extreme ranges and outliers. The final central tendency statistics that I want to show you is the mode. This is the most frequent score in a distribution. Like the median, it isn't calculated, it's just identified. And luckily for us, identification is super simple. All we have to do is look for the number or value that appears most often in the data set, and that's our mode. So let's look back at the example of Julie's car accidents again. If we want to identify the mode in this data set, all we need to do is to count up how many times each value is present and determine which one is present most often. Looking at the data, we see that one friend reported no car accidents, one friend reported none, one friend reported 3, and one friend reported 5. 2 friends reported 1 car accident and 2 car accidents, and 5 friends reported having 4 car accidents. By the way, we don't want to be Julie's friends because evidently they are not very good drivers. So what's the most common value, right? 4 car accidents. So our mode is 4. What if Julie's accident data looks like this? Then what would the mode be? Well, let's analyze the frequency again. We see that one person each has reported 0 car accidents, 3 car accidents, and 5 car accidents. But this time, 5 friends have each reported either 1 car accident or 4 car accidents. So what's the mode? Unlike the other central tendency statistics, the mode can be multiple numbers. So our mode for this problem would be 1 and 4. We call this a bimodal data set. The data set can actually have an unlimited amount of modes. The only instance in which I would hesitate to include a mode is when there is an even frequency across all value types. So if every person had set a unique number of car accidents in the data set, then there would be one instance of every value. Rather than saying that every value is a mode, I would say that there is no mode due to the lack of variation between values. Now, one of the super important things about the calculations I just showed you is that even if you can calculate all 3 of the statistics, you can't always make conclusions from all 3 statistics. Why? Because it's going to depend on the level of measurement of the original variable. This is a challenging point for many students because it's a little confusing. So let me walk you through what happens with an example. When you start with a survey question like this, the response options given to the respondent are chocolate or vanilla. When we quantify this survey question, we create numerical placeholders for the response options. So chocolate becomes 1 and vanilla becomes a 2. Let's say I give the survey to 5 people. When I look at the quantified data set, I will see responses like this. There's 2 people that said chocolate, so there's 2 1s, and there's 3 people that said vanilla, so there's 3 2s. I run my calculations on these numbers and I find the following. The mean is 1.6, the median is 2, and the mode is 2. But here's my problem. My actual data isn't numbers, right? It's categories of ice cream flavor. So what I need to do is first uncode my coding in order to analyze the actual meaning of the calculations. So a mode and median of 2 becomes vanilla. A mean of 1.6 though, what does that mean? Well, here's the problem. We can interpret all 3 statistics on any quantified survey question, but we can only interpret the statistic in some cases. It all depends on the level of measurement. This chart here shows you how this breaks down. We can interpret the mode for every variable, no matter what level of measurement. The median has to be either ordinal or interval ratio, which makes sense because the median is about finding the middle. And how do you find a middle if you don't have rank ordered options? And the mean, well, that's the most picky. Mean can only be interpreted when the data is at the interval or ratio level of measurement at the beginning. So for my original level of measure, or for my original question, what's my level of measurement? It's nominal, right? The answer choices are categories and they cannot be put in rank order. So if we look at my chart here, it means the only statistic I can actually interpret is the mode. So the most common ice cream flavor in my data set is vanilla. I can't make any conclusions about the middlemost value or the average value due to the level of measurement restrictions. All right, well, that concludes our discussion about central tendency statistics. Join me in the next lecture video as we calculate dispersion statistics.